Hello everyone. So today we'll be talking about PyTorch. Now if you have been following the past videos which have been made, we have talked about Keras and TensorFlow. Now similarly there's another thing called as PyTorch. Now what is PyTorch? We'll see about it in this video. Now before that, let's see what all will be discussed in this video. So the table of contents, we'll talk about what PyTorch is, its features, advantages, and applications. So what is PyTorch? Now PyTorch is a small part of a computer software which is based on Torch library, and it is a deep learning framework which has been introduced by Facebook. You all must be knowing Facebook. Now deep learning and those things. Now let's see what deep learning is. So deep learning frameworks, they offer building blocks for designing, training, and validating neural networks through a high level programming interface. Now there's a lot of technical terms here. So firstly, deep learning is a part of artificial intelligence, and when we are talking about neural networks, so a neural network is a method in artificial intelligence that teaches the computer to process data similar to a human brain. So we know how human brain works, and there are neurons and all. So when we try to replicate that into teaching machines, so a neural network is used. Now a deep neural network is a neural network but with more hidden layers. When there's a simple, let's say three layers, one is the input layer, one is the hidden layer, and one is the output layer, that is a simple neural network. But when we talk about a lot of layers in between where there are a lot of hidden layers, then it will be called as deep neural network. So yes, a neural network with more than two layers is known as deep neural network. So it has higher complexity, and when I said high level programming interface, it basically means that you know it is designed to enable the programmer to write code in a shorter amount of time. So it helps you write certain code in very less time if you're a programmer, and be less involved with the details of the software module or hardware device that is performing the required services. So that was a programming interface, a high level one. And yes, so this is how a simple neural network looks like. So we have an input layer, we have a hidden layer, and we have an output layer. Now in this there can be various calculations, mathematical calculations. It can be as simple as just addition or multiplication. Like for example, if we put two numbers over here, this arrow is going over here, so it's just that single number over here. And in this in this hidden layer at this node, both these inputs have taken over here, since you can see the arrow pointing. So let's say if this is 2 and this is 5, so 2 will be written here, and we can write 2 into 5 if multiplication is what is being done. So 2 into 5 will be 10. Over here again we'll write 2 into 5 10, and in this we'll write 5. Now in the last output layer, we can just get the sum and output it. So it can be as simple as that. That's just a very basic example of how you can use a neural network. Now when you're actually using it, there are a lot of complex calculations at each layer. Now we saw the simple neural network. This is how a deep neural network would look like. So when you see, it is not very clear, and you might feel it is so much complex. You probably cannot even differentiate which arrow is pointing where. So there's a lot of interconnections between the two layers, and there's a lot of neurons if you see these circles, and lot of them. So we have input layer, and in this we have three hidden layers, and then we have the output layer. So this is what a deep neural network looks like. So top 8 deep learning frameworks, we have TensorFlow, Keras. Both of these we have already seen in the previous videos. If you haven't already seen them, you can just check them out after this. MXNet, PyTorch, Caffe, then Microsoft Cognitive Toolkit, DL4J, ONNX, and so on. Now what is PyTorch? So PyTorch is machine learning library for Python programming language, which is used for applications such as natural language processing. Now again in this we have a few technical terms, we'll see about them in the next slide. So machine learning is a type of artificial intelligence which allows software applications to become more accurate at predicting outcomes. So when you program a software, when you program a machine such a way that when you provide some input, it will predict something. It can be anything like what the weather will be, or maybe it's the stock market prices of a certain stock based on its past performance, or something like even the price of a house maybe. So all these things, if you want a machine to predict it, you're basically doing machine learning. So when an ordinary system is integrated with AI, or basically if you're writing a code in an ordinary system about artificial intelligence, so we have machine learning. So the machine first learns, then it predicts, and based on the predictions, based on how much the accuracy is or how good it is predicting, we can improve it. Now, natural language processing. So this is even more targeted field inside AI, and it is a subfield of artificial intelligence, like I said, and it helps machines process and understand the human language, so they can automatically perform certain tasks. Now, when you're talking about natural language processing, uh, if you're entering anything into a computer, it does not directly understand it. It has to be converted into computer understandable code, which is binary. So when we are talking about natural language processing, for example, if you want to do sentiment analysis, now sentiment analysis, the name itself defines it. For example, if a company wants to see about its new product, how people are reacting to it. So whenever something new comes, it usually trends on Twitter, especially from the big companies, and people have all sorts of reaction. Now, as a person from the company, how will you know that what kind of general reactions there from the public? Now, for that, you'll have to use natural language processing, where you can analyze the sentiments of the users from maybe Twitter. And there are, let's say, in this example, there are certain keywords. Now, if people say something like good, amazing, awesome, it obviously means that they liked it. So you put these keywords together and try to find them in the comments made by the people. And then there are the keywords on the negative side, like bad, needs improvement, or not happy, something like that. So those kinds of things, when they're there, so we understand it's a negative sentiment. So the machine which we are training for processing this natural language, it will directly take all these tweets or all this data together and analyze it. So that is what natural language processing is. Now, features of PyTorch. So it is easy to learn. PyTorch has the same structure as traditional programming, and it has been documented with such smoothness. You can just go through the documentation and easily understand what PyTorch is. And also the developer community is continuously working on it to improve. So due to this, it is very easy to learn for the programmer as well as a non-programmer. Moving on to the next feature. So developers productivity. So PyTorch has an interface with Python and with various powerful APIs, and it can be implemented on Windows or Linux OS as an operating system. So with some programming knowledge, developer can improve their productivity, as most of the tasks from PyTorch can be automated. Now, what is API? So API is basically application programming interface. And again, interface. Now interface is in general a device or a system that links unrelated entities, so where they can interact. Now, yes, so API is a way for two or more computer programs to communicate with each other, and it is a type of software interface which offers a service to other piece of software. So let us see what API or how API works in short. So if you see, there's a system over here. It sends a request and using the API connection. So the API connection then submits this request to another system, so which might be holding certain kind of data which the first system wants. So after verifying the request, system B will then send back the data again via the API. The API will then confirm to system A that system B has executed the request. Now the real life analogy to this would be when you go to a restaurant, you give the orders to a waiter. The waiter will then go and pass on this to the chef. The chef will then prepare the dish, give it back to the waiter, and the waiter will be serving you again. So you do not know what is happening in the backside of this, what is happening in the back end part. That is, who is the chef, where are they preparing, how are they preparing, what are they doing. You do not know anything at all. You just sit on your table, the waiter collects your order, and after a certain amount of time, the order is delivered to you by your waiter. So similar is the case with API and the two systems which interact because of it. So third feature, it is very easy to debug. So it can use debugging tools like PDB and IPDB tools. We'll see about them in the next slide of Python. So as PyTorch develops a computational graph at runtime, a programmer can use Python's IDE PyCharm for debugging. So PDB is basically program database. So it is a file format which was developed by Microsoft. So it is used for storing debugging information about a program. And debugging basically is like, finding out the bugs or finding out the errors and then solving them. Now IPDB is an enhanced version of PDB, and it supports all the PDB commands and is also easier to use. So yes, there was actually this illustration. You can see what PDB is. So it's finding the bugs and then helping you debug it. So PyCharm is an integrated development environment. We talked about PyCharm in the previous slide where yes, over here. So PyTorch develops a computational graph is what we said at runtime, and programmer can use Python IDE PyCharm for debugging. So now PyCharm. So PyCharm is an integrated development environment or IDE which is used for programming in Python. So it provides code analysis and a graphical debugger. So moving on to the next feature, data parallelism. Now what is data parallelism? It means that PyTorch can distribute the computational tasks among multiple CPUs or GPUs. CPU is central processing unit and GPU is graphical processing unit. So this is only possible because of the data parallelism feature, which wraps any module and helps us do parallel processing. So a GPU or a graphics processing unit, it performs the necessary computations in the main component in a graphics card. So when you buy a laptop, you see the kind of graphics card it has and the kind of performance you'll get because of it. So that is what GPU is, and the CPU, we all know, central processing unit, is the primary component of a computer which acts as a control center. Now data parallelism, it is as you can see in this image, if we have an input data, it is divided into sections, and all each of this section or each of this part is then processed parallelly. So each of this part is then there's a task and each of this part is going through it, and then there is the result data, which is again stored in a form of an array where you get many results, and then the final result would be just the aggregation of these. So you have huge data, you're separating it into components, you're processing it on simultaneously side by side, and then at the final result time you're just aggregating all the results. So it focuses on distributing the data across different nodes which operate on the data in parallel. So moving on to the next feature, useful libraries. So PyTorch has a large community of developers and researchers who build tools and libraries to extend PyTorch. So this community helps in developing computer vision and reinforcement learning. So when you're using PyTorch, you just have additional features of the other libraries which are being built by developers and researchers. So that just adds functionality to PyTorch, and you can do various other things. So top 10 Python libraries are Pandas, NumPy, we know Matplotlib, Seaborn, TensorFlow, Keras, SciPy, PyTorch, SQL Model, and Scrappy. Now advantages. So like we mentioned earlier, it is easy to learn and simpler to code, not just for a programmer but also for a non-programmer. Even if you do not have a technical background, you can still just go through the documentation and easily understand what PyTorch is or how to use it. So it has a rich set of powerful APIs to extend the PyTorch libraries. It has computational graph support at runtime. It is flexible, faster, and provides optimizations. So optimizations basically means the most efficient way of doing a task. It can include maybe doing it faster or using lesser resources. It has support for GPU and CPU. It is easy to debug using Python IDE or integrated development environment and debugging tools. And it also supports cloud platforms. Now, cloud is another different topic, but in short, when you're uploading your data or when you're uploading your photos or you're, taking backup of anything, you're kind of uploading it on cloud, like even Google Drive. So that is what cloud is, and cloud platforms similarly are platforms which run on cloud, which can be used from anywhere. Now computation graphs, we heard this term earlier again and in the previous slide as well. So they are the graphs with equational data. So they are a form of directed graphs that represent a mathematical expression. And cloud platform, like I mentioned earlier, it refers to the operating system and hardware of a server in an internet-based data center. So it allows software and hardware products to coexist remotely and at scale. So it's basically what I said earlier, when there is data centers at a different place and you are just simply using it, simply accessing it from your home. Like even for example, let's say Netflix. Netflix has so many movies, so many series. It has to store them somewhere. So it is stored in certain data centers and you get to access it, through cloud. That's as simple as that. Now applications of PyTorch. So the first application is computer vision. So it is used as convolution neural network or CNN to develop image classification, object detection, and generative application. So using PyTorch, a programmer can process images and videos to develop a highly accurate and precise computer vision model. So neural networks can help computers make intelligent decisions with limited human assistance. And object detection is a computer technology related to computer vision and image processing that deals with detecting instances of objects. So basically, when a computer is detecting objects from a video or from a photo, so that is what object detection means. It, the word defines itself. And yes, also image classification basically means classifying an image. Like for example, if you're given a photo and you have to classify it as I don't know, like whether it is a dog or a cat, so something like that. That is image classification. Now you can see in this example, if this image is provided to a certain model, this is the output that you get. It is basically classifying the image or the objects in the image. It's identifying the objects first and then classifying them. So you can see this box, yellow box. This is a car, rightly labeled by the model. Again, a car over here, a person walking. There's an umbrella. Yes, there is, and also a person inside this car. So whatever the system is able to detect, it is marking it over here. So that is what image processing is. The second application, natural language processing. I already talked about this earlier. When you want to, process the language which we use, basically English language or any other language, and something like sentiment analysis. So it can be used to develop the language translator. Now again, translating, when you're doing translating, so that is basically natural language processing as well. Language modeling, and to develop a chatbot. So chatbot is another good example of uh, NLP or natural language processing. Now it can be again done using PyTorch. So the third one, reinforcement learning. Now firstly, what is reinforcement learning? So you must have heard of the word reinforcement. Uh, Take an example of a child. If a child does something that is harmful, something that is not good, so you will see that the parents will scold the child. So that is a kind of negative reinforcement. So whenever the child is not behaving nicely, there is negative reinforcement involved so that the child will come back to being normal or behaving good. Now similarly, when we talk about positive reinforcement, it means that rewarding the child in this example for behaving good, for doing the right things. So similarly, when we are training a model, if it is going on a correct path, or if it is doing right things, you provide reinforcement. Now for example, let's say if you are trying to build an application, or if you're trying to build a robot which follows a certain line. Now if it moves away from the line, you have to provide negative reinforcement, and if it's continuing on the line it has to follow, you'll provide positive reinforcement. So that is an example. Okay, so it is PyTorch is used to develop robotics for automation, business strategy planning, or robot motion control, etc. So robot motion control, like I just said in the example. So that's it from this video. Thank you so much for watching, and in the upcoming video I'll be talking about the comparison between the three things which we saw earlier and today. So PyTorch, TensorFlow, and Keras. So once again, thank you for watching.